Okay, today we will see a basic mathematics mid-exam for natural science students with the code math 1011. This mid-exam is only on logic and set theory or only on chapter 1. This mid-exam has 3 parts. Part 1, which is true or false. Part 2, blank space. Part 3, workout. Now this is mathematics for freshman students. So dear all, don't forget to subscribe, like, share and comment. If you subscribe, please like it. Now let us start from part 1. Part 1 said that write true if the statement is correct, false if it is incorrect. Now each question has 1 point. Question number 1 said that if P and the Q is true, but P and R is false, then P and R or negation Q is true. Now, to determine or to say this is true or false, let us check here. From this, P and the Q is true. Then we obtain what? P is true, Q is true. Therefore, P and the Q are both are true. And here we say that P and R is false. P and R, from this, P is true. Therefore, true and R is false. Then simply, the values of R should be what? Which is false because P is true. Therefore, P and the Q are true and we obtain R is false. Then we can determine the truth value for this. Therefore, P and R or negation Q becomes this here. P is true, and R which is false, or negation Q is false. Therefore, false or false which is false. Therefore, true and false which is false. Therefore, this has what? Which is false. Number 2. The compound statement P by implies Q by implies P implies Q and the Q implies P is tautology. Yes, this is true because this P and the Q is equivalent with what? This P implies Q and Q implies P. Therefore, this compound statement which is tautology. Therefore, this is true. Number 3. For any sets A and B, if A without B is A, then A intersection B is empty. Now for A without B, or a set which contains an element only in A, not in B, which is A. Therefore, this means what? A and B has not any intersections. Therefore, this is true. Number 4. Let the universal sets use a real number, then negation of there exists x squared plus 4 is equal to 0 is true. Now to determine this, let us we can find this. What means this? Negation of there exists x squared plus 4 is equal to 0 means what? For every x squared plus 4 is different from 0. Therefore, for any x from a real number, x squared plus 4 is what? Not always give us 0. Therefore, x plus 4 is not equal to 0 for any x in a real number. Therefore, this is what? Which is true. Therefore, this statement has truth value. This statement is which is true. Part 2. Give short answer to each of the following. Each of those following questions has 1.5. Number 5 says that let the universal set use integer, which is z, and let e of x such that x is an even integer. O of x is an odd integer. Then the truth values of a, there exists x, e of x, and O of x is dash. Now here, since e of x is uneven, or O of x is which is uneven, therefore so that there exists an x from integers which is both even and odd. Therefore this is what? Which is false. Therefore there is no any integers which is both odd and even. Therefore this is which is false. B. For every x there exists x, then e of x implies negation of O of x. What means negation of O of x? Negation of O of x is which is e of x. That means even. Therefore, it says that for every x A of x implies A of x, which is true, because even number implies that even number which it gives us, which is true. Number 6. Let the statement P, Q, R, and S are assigned the truth value true, false, false, and true respectively. It means that the truth values for P is true, Q is false, R is false, and S is true. Then we can determine the truth values for these compound propositions. Therefore, to determine the truth values for this, here P is what? True. And Q is which is false, therefore negation Q is which is true. Therefore, this means what? P is true, therefore true, or any truth values which is true. Therefore, this has true. This statement has truth values. That means true or true is which is true. Therefore, this is true. And let's can determine this here. R implies S and the negation of S. S and the negation of S means what? Since S is true, negation of S is false. Therefore, true and false is which is false. Here R is which is false. Therefore, false implies false, which is false. But this is true. Therefore, true and false. No, true and true. This is true. True and true, which is true. Therefore, this statement is what? True. Number 7. Let's set A is given us set containing an element 1, set containing 2, 3, and 4. Then the number of subset of set A is dash. Now, how many elements are this set A has? Now, this set A has what? 3 elements. Therefore, using the formula, the number of subset of if A has infinite number of elements, then or the number of subsets for given set A is what? To the power of n. Therefore, here our n is 3, then to the power of 3 which is 8. Number 8. Given the statement, if a number is not positive, then it is less than 0. Then A. The converse. What is the converse for this statement? Now here, the converse means simply by interchanging or writes the hypothesis as conclusions and the conclusions as hypothesis. Therefore here, if a number is not positive, then it is less than 0. Its converse is what? If a number is less than 0, then it is not positive. This like this. If a number is less than 0, then it is not positive. B. What is the inverse? Now the inverse for this statement is what? Simply find the negations for given statement. That means if a number is positive, then it is not less than 0, or if a number is positive, then it is greater than or equal to 0. Therefore, if a number is positive, then it is greater than or equal to 0, or if a number is positive, then it is not less than 0. C. The contrapositive. The contrapositive is simply the negation of converse. That means if a number is not less than 0, then it is positive, or if a number is greater than or equal to 0, then it is positive, which is given here. If a number is greater than 0 or equal to 0, if a number is greater than or equal to 0, then it is positive. Part 3. Work out the following equations by showing all the necessary steps. Number 9. Show that the following argument form is valid or not. Now the given argument is given here. P implies Q, Q implies R, negation Q. Those are as hypothesis or the premises, and the conclusion is negation of R. So now for simplicity, let us check the validity for this given argument using or constructing truth table. Now the truth table for this given statement is given like this. Since here we have 3 propositions, which is P, Q, and R, therefore 8 possible truth value combinations are obtained here. Therefore, P, Q, R. Then P has possible truth value, which is true, 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 false, 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 false. And the Q has possible truth value, which is true, true, false, false, true, true, false, false. R has also true, false, true, false, true, false, true, false. Then next we can determine P implies Q. Now P implies Q is always false if P is true and the Q is false. Therefore, P implies Q has possible truth value. Has truth value which is true, true, false, false, true, 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 true. Because here true implies true is which is true, true implies true, false, true, true implies false, false, true implies false, false, false implies true, false implies true, false implies false, false implies false. All are hot, which is true, 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 true. Q implies R. Q implies R is false if Q is true and R is false. Therefore, Q implies R has truth value like this: true, false, true, 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 false, true, true. The definitions. Now, using this truth table, we can determine whether the given argument is valid or invalid. Now here, so I told you that P implies Q, Q implies R, and the negation Q are premises. Then from this truth table, we can find where those P implies Q, Q implies R, and negation Q are true. Then corresponding to those premises, we can determine it is conclusions or negation R. Now here, only in seventh and eighth row, those here we can determine negation Q based on Q, because Q has, if Q is true, 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 false, false, true, true, false, false, then negation Q is false, false, true, true, false, false, true, true. Then negation R is also has truth value, which is false, true, false, true, false, true, false, true. So here only those premises P implies Q, Q implies R, negation Q as true on row 7 and 8. Now let us check the corresponding to row, the premises in row 7 and row 8. Then we can check their conclusions. Now here in both row 7 and 8, the premise has truth value, which is true. But in 7th row, the conclusion, which is negation R, is false. As a result, the given argument is which is invalid. Like this. The premises P implies Q, Q implies R, and the negation Q are true simultaneously in row 7 and row 8 here. But the conclusions, which is a negation R, is which is false in row 7. Hence, the given argument is which is invalid. There are. We can check this validity using the formal or using inference rule or using formal definitions. Number 8. Show that P implies Q or R is equivalent with P implies Q or P implies R. Now we can, for sample case, we can show this using our constructed truth table. Or otherwise, you can prove using formal loop. That means by noting that by using the definitions for P implies Q, since P implies Q is equivalent with negation P or Q. And using that definition, that means here this also P implies Q or R is also equivalent with what? Negation P or Q or R. And since P implies Q is also negation P or Q. And this P implies R is also equivalent with negation P or R. Then by using constructing or by using the associative law for disjunctions, we can prove in simple case. But in our case, we prove this or we show this by constructing truth table. Now here, since we have 3 propositions, say P, Q, and R, therefore they have what? 8 possible combinations truth tables are given here. Now here, since we have P, Q, and R, P has possible truth value, which is true, 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 false, 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 and the Q has true, true, false, false, true, true, false, false. and R has also true, false, true, false, true, false, true, false. Then we can determine the truth value for the given compound propositions in the bracket Q or R. Then we can determine next P implies Q and the P implies R. Then the combinations. Therefore, Q or R has both truth value false if both Q and R are false, otherwise true. Therefore, Q or R has truth value which is true, 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 false, true, 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 false. And the P implies Q has the truth value since P implies Q is false if P is true and the Q is false, otherwise true. Therefore, has truth value true, true, false, false, true, 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 true. P implies R has also truth value which is false if P is true, R is false, otherwise true. Therefore, P implies R has truth value true, false, true, false, true, 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 true. Then let us determine this P implies Q or R. And finally, P implies Q or P implies R. Now, P implies Q or R has truth value which is true, 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 false, true, 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 true. And this P implies Q or P implies R. Here we have P implies Q and P implies R. Then we can join by distinctions which is false. Therefore, this has truth value which is false if both P implies Q and P implies R has false, false. Otherwise, so therefore, this has truth value which is true, 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 false, true, 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 true. Then we can observe that this, if this is column 1, column 2, column 3, column 4, column 5, column 6, column 7, column 8. Therefore, from column 7 and the column 8, those compound propositions has identical truth value. Therefore, as a result, those compound propositions are equivalent. Oh, that means then P implies Q or R is equivalent to P implies Q or P implies R, since column 7 and column 8 of the above table are not identical. Number 11. For any three sets A, B, and C, show that B without A or C without A is equal with B union C without A. Now here, let us we start from the left hand side solutions. This has 3 points. And now let's start from this left hand side, P without A or C without A. Then what means B without A and what is C without A? Now P without A is the same as what? B intersections A complement, and C without A is the same as C intersections A complement. Therefore, this is equal with what? B intersections A complement or union C intersections A complement. Dear all, here we have A complement as a common, isn't it? Here not only A complement, intersections A complement are a common. Therefore, let us take this common one here. If we take intersections A complement as a common, then we left what? B union C intersections A complement. Again, as I told you that since B without A is the same as B intersections A complement, that means B intersections A complement is the same as B without A. Therefore, B union C intersections A complement is the same as what? B union C without A, which is gives like this: B union C without A, isn't it? Therefore, which is proved. So, thanks for watching my video. But anybody who subscribed my video, don't forget again to like it, my video. Thanks.